Well, welcome. We're going to finish up notes on 6.3. I'm on page 344. And now I will begin example 2, part A, subtracting polynomials. So let's follow our nose and look at the example here. So alrighty, so here's what the example says. It says, let's get this out of here. Okay, what we have here is a polynomial. It's written horizontally, but we're going to use the vertical alignment method. And so, looking at that polynomial, it's been rewritten so that the degree of the term x squared is written first. Okay. Is there another x squared term in this polynomial? Yes, it is. It's right here. Okay. Then we look at the constant number 2, and the constant here is number 1. And then, of course, we have a solo term, which I won't, well, I guess I'll highlight. It's negative 3x, or minus 3x. Alrighty, so we're going to group these vertically. So the first step is to add the opposite of the second polynomial. So what that means is you take this negative sign, affects everything inside the parentheses, and it changes its sign to its opposite sign. So this would be minus 6x squared or negative 6x squared, but now it's positive 6x squared. This is now positive 3x. And finally, this would be negative 1. Alrighty? And since we've done that, this now becomes an addition problem. And that's the rule. Okay. So subtracting is akin to adding the opposite of each of these terms and their sign. And so with that said, there we go, 9x squared matches up with positive 6x squared. And positive 2 corresponds with negative 1, or subtract 1. And 3x, positive 3x, is here. There is no other x term in the first polynomial, and so we leave it blank there, and that's what this space represents. So we're vertically aligned. Now let's add the coefficients. So 9 plus, I always use the plus sign with the circle around it. 9 plus 6 is 15x squared. 3x plus nothing, or 0, is 3x. And positive 2 plus negative 1 is 1. Now, oftentimes I like to take this problem here and even write it as an addition problem. I take this minus sign, move it over to the 1, and call this plus negative 1. Just a preference of mine. It's, you don't change the value. It essentially is the same. Adding negative 1 is identical to subtracting positive 1. So that's my answer. Let's go on to the next question, or next example. And here it is. Same idea. So again, we'll distribute this negative sign. Negative 4x to the third, negative 6x squared, positive 2x, and negative 7. Okay? So now this becomes a plus sign. Again, you add the opposite. Adding the opposite. Now, with that said, let's identify our grouping. Okay. So 6x to the third is grouped with negative 4x to the third, or minus 4x to the third. 3x squared minus 6x squared. 2x is grouped up with 2x. and 9, positive, grouped up with minus 7. Okay, so 6 minus 4 is 2, x to the third power. 3 minus 6 is negative 3, or minus 3x squared. 2 plus 2 is 4, so positive 4x. And 9 minus 7 is 2. Okay. Next question. Reflect. So how is subtracting polynomials similar to subtracting integers? Okay, well, here's how they're similar. First of all, didn't we group the polynomial terms together, the like terms? Once we grouped the like terms, we added or subtracted their coefficients. And the coefficients are integers, so that's the answer to this question. It's once terms are grouped, once like terms are grouped, add or subtract the coefficients of the like terms which are integers. If you look at the examples that you just completed, you first grouped the terms and then added or subtracted the integer coefficients of those like terms. So it is similar to subtracting integers once you collect like terms. In part A, you leave a gap in the polynomial 9x squared plus 2 when you write the subtraction problem vertically. Why? Okay? And here's why. Because when you collect like terms, if you don't have a specific term, then you leave it blank so that you can represent the value of 0. And that's what we do essentially. So we'll write since no x term was available for grouping, a space represented the 0x term. Because again, 0x plus another x term like 5x would give you still 5x, right? And so we add a space there to signify that there is no term there, otherwise known as the 0x term. Just about done with this. Let's look at the next question. It says, is there a difference, excuse me, let me read that one more time. Is the difference of two polynomials always another polynomial? And again, I would argue no. And the reason is because when you subtract polynomials, you can end up with just a constant. And so we'll start with a simple example. 5x plus 7 minus 5x plus 7. And if I was going to work this example, again, I should say no. And here's the example, no. Working this out, you would see that you get 5x plus 7. Okay, we're going to distribute the negative sign. We end up with plus negative 5x plus negative 7. Again, I like to keep the plus sign and just change the the sign of the coefficients and the constant. And so we've got some numbers that cancel, terms that cancel. And when everything cancels, you end up with 0. And so here's a case where two polynomials give you an answer of 0, which is an integer, obviously not a polynomial. Okay. I would say no. For example, here it is. The next ratio would be all variable terms can possibly be canceled or eliminated. Leaving just a constant. And all variable terms can possibly be eliminated, leaving just a constant. So that essentially is example 1 and example 2 worked out in 2 different parts of a video. The next portion of the notes will be done on a separate video. Remember, study hard and learn a lot. Bye-bye.